Hello everyone, welcome to the third part of our senior mock paper review, and we get to a bunch of questions where the distinguishing feature I think is they just look really frightening. Also a defining feature of the SMO senior as compared especially to the SMO junior. Now the thing is that this is also a bit of a stereotypical understanding of math and math Olympiad specifically, right? And if you guys have done round two, the more round two you do, you know that actually it's not always the scary looking questions that are the hardest ones. In fact, sometimes the scary looking questions are pretty easy. It's the ones that are not so scary looking that turn out to be deceptively hard. Having said that, it still requires us to take a bit more time to process what's going on. And so I'll talk about how we can handle some of these ones that, like question 14, look pretty scary. Question 14 has an expansion that is so ridiculous that no one is going to expand it, which is a good thing, right? The thing about the SMO and math in general is that if something looks like it is going to be only possible for a computer to do, that means you are not supposed to do it. You're supposed to find another way. That doesn't make it hard. That actually just tells you that, it's just impossible to do that. So if I ask you for this specific thing, the sum of aij over all pairs of even integers, where aij is the coefficient of x to the I, y to the j when this is expanded, we need to find something nice about it. And so let's start off with thinking about how we can extract out the coefficients. Now, if I put in any value of x and y, it will tell me something about the coefficients. And so, for example, if you put in x equals to y equals to 0, then you're going to just get p0, 0. The only term that survives is the constant term, right? So this is, for instance, if you put in x equals to y equals to 0. Now, I'm not interested in a0, 0 specifically. I want over all pairs, which is a lot. But, this is an example. So if you have seen SMO senior problems like this before about extracting coefficients, then you know that a very common thing to do is to put 1 inside. It's actually going to give you the sum of all aij. And so what I'm going to do is that I will just tweak this, because if I want to separate odd and even, I should put -1. So if I put in -1, I will get something. If I put in x equals to 1 and y equals to -1, I will get something. If I put x equals to -1, y equals to 1, I will get something. And I just want to check what will happen. And so how I'm going to do it is that I will just sort of fill in a table just to see, right, aij. If let's say that your ij is odd, 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 even, odd, and even, even. This one is going to take all 4. For this one, if m and n, or your I and j specifically, are both odd, then -1 is going to be -1 to the odd, -1 to the odd becomes positive. So it's going to actually take this and this. But if one of them is odd, one of them is even, it's going to take the negative of them. For this one here, if y is -1, then it is going to look at whether the y exponent, the degree, is odd or even. So if the y degree is odd, you don't take it. If it's even, you take it. And then for -1, 1, it's the other way around. And so just nice, you realize that the one that you want is here, even integers. And the other two have 2 ticks and 2 crosses. And so therefore, if I just want to get this column, my S is just going to be the sum of all those divided by 4, which you can also call the average. Okay, and each of those things are quite easy to compute. You just put the 1, 1 into the actual polynomial and see what you get. I've chosen it such that, in fact, P11, if you put in the first thing, it's already 0. And if you put in minus 1, 1, that's also 0. If you put in minus 1, minus 1, the thing behind is also 0. So the only one that actually survives is 1 minus 1. And so if you put 1 minus 1, the one in front is 4, and the thing behind is also 4. And so therefore this would just be 4 to the 2025. So the extracted answer log 2s will be equal to 4050. This is not easy if you have not seen the idea before. This is sort of what can be generalized to complex numbers as a roots of unity filter. But using 1 and minus 1 is sort of the simpler case of that, where you're filtering different types of coefficients out of a polynomial. Okay. So 15. The number of pairs of integers xy which satisfy this equation over here. The start of this is not too difficult. You can always just let your x be the subject and then reciprocal it. And so it's now asking, basically, for every value of y that makes this thing into an integer, then you will get an x. Right? So it's just like, how many y's can you have? In order to determine how this is an integer, the classic way is to do a long division, which I will just fast forward because the long division is not very long at all. It's just the quotient is 2025 and negative 2025 times 4050 is the remainder, which allows me to pause and say, okay, I have to make sure that this is also an integer. And so therefore I want to find factors of this value here, which is something that I will just do quickly. It's 2 times 2025 squared. We know that 2025 is 45 squared. So you get 3 to the 8 and 5 to the 4. Okay, so this is our factorization, which means that 4050 plus y is a factor. The number of factors, we know we take the exponents plus 1 and multiply them. And so 90 is the answer that many of you gave. If you got 90, I would say that is wrong, but that is also, you can be a bit, I don't know if it helps if you realize that you've actually made 2 mistakes. So maybe if you made 2 mistakes, that causes you to be less frustrated than if you only made 1 mistake. The first mistake that you have made is that you have forgotten what the question said about not necessarily positive. Right, so 4050 plus y can be positive or negative. So this is actually going to be positive factors, but actually the number of factors you have to multiply by 2 to get 180. And yet that's not fully correct yet, because there is something to reject, which is that you need to reject y equals to 0, which would give you a factor here. So how do we know that that's the only thing to reject? Because the fact is that by reciprocaling it to here, that is assuming that x and y are non-zero. So this is when you're doing your workings, a good habit is to either mentally note or to literally note down uh, any exceptions to what you've written. For example, you say, oh, factorial is always even, unless n is 1. That kind of thing. Or my prime numbers are always odd, unless it is 2. Like, write down the exception so that you, in case it matters, which in this case, it does matter because one of the factors is 4050, which will give you y is 0, and that does not work. So you have to reject y equals to 0, which tells you that your answer is actually 179. You don't have to reject 2 for the plus and minus, which is the other thing. Some of you may end up 178. No, y 0 is only going to happen once. So be extra careful. Okay. Next up, question 16. This is actually not so bad. It's just a giant mountain of logarithms. Giant mountain of logarithms to confuse you. And so what can we do here? I will sort of observe that if you were to just look at each layer, the variable is essentially the same. But in the second thing, which is the right hand side, it has a bunch of random powers, which obviously is my fault for putting a bunch of random powers over there. Therefore, in order to resolve this, your task is just to get rid of those powers one at a time. I think that's a little bit too much to put into one equation. So what I'll do is I'll just call this whole thing here z, and I will write this in terms of z. Usually when I see these powers, what I do is just change it to sort of a default base, just to pluck it out, and then it becomes, this is 5/4 log xy, so 5/4 z. Okay. So now I've got log yz equals to log y to the pi of 5/4 z, which I can change the base to log y as well. And that means that z, okay, maybe I can just bring it in. Z equals to 5/4 z to the 1/pi. That is fairly disgusting looking. Okay, before we get lost in the weeds, let's remind ourselves, right? What do I want to find? I want to write y in terms of x. Well, z equals to log xy, I've called it that, which means that y equals to x to the power of z, which means that I do expect my z to look like this. And so I actually feel that, that's not so bad. This is not horrible. Like it felt like it was pretty bad, but it turns out to be quite okay. Right? I'm not making any mistake because z should look that ugly. So I can just write it like that. And okay, yeah, so basically take both sides to the power of pi over 1 minus pi, which means multiply both sides like this, and then after divide by 1 minus pi. Which technically, of course, you have to flip it around. Uh, but in order to get it to look like this exact form, nonetheless, yeah, I mean, the values that you want are already 4, 5, and 1. That's your M, N, and R. You can check through your work for something like this because it will tend to go very wrong, but I think the answer format is helpful in the sense that most likely, if you got to this answer format, you are correct. Not guaranteed, but it's so weird that, it should be fine. Next up, question 70. Largest possible value of A such that for any real value of Y, this equation has at least one solution for X. Before we do anything, let me just tell you that this question took a very long time to set. It takes longer for me to set. It takes for you to solve for sure. Because if you're thinking that I have 3 layers to do as a solver, that means the person setting it has 4 layers. Because I had to think of what are the coefficients I can put in so that I can ask you what is the largest possible value of A, such that for any value of Y, there's at least one solution for X. What a mouthful that is. Anyway, if you are trying to solve this, I mentioned about layers, right? So take it layer by layer and you will actually be okay. Has at least one solution for X. This is still a quadratic in X. And so has at least one solution means that the discriminant is greater than or equals to 0. Let's just do that first by making it look like a quadratic. Okay, so x squared are in 4 different places. There's a couple of x terms there. And so your discriminant must be greater than or equals to 0 for now any real value of y. Okay, so I'll divide by 4 first, just to make it a bit cleaner, and then I will expand out. And you get a quadratic in terms of y. So you have plus 2y plus 6y minus 25y is minus 17y, and then minus 2ay. Is that right? Okay, no, there's a y missing here. Okay, that is, no wonder I was finding that this looked a bit weird. Okay, so no, that is not supposed to look like that. That's actually going to be 5a minus 24. Okay. I was wondering why did I not cancel something if it was already a like term, right? So even in your own question, you can make a careless mistake, but sanity check it. So minus 24, this one actually is just going to be 2 plus 6, 8 plus 2, 8. Okay. This right, yeah. So 8 minus 2a if I just write it like this. And then just plus what, because there's no other constant terms there. Phew, okay. Now, for any real value of y, this is greater than or equals to 0, means that you can do a second discriminant, and that means that for this one, the discriminant is less than or equals to 0 from the perspective of y. So this is sort of the discriminant when viewed from x, and now this is the discriminant from viewed when it's a quadratic in y. I go again. This squared minus 4 times this is less than or equals to 0, and then you go again. Okay, so divide off and just factor. no more discriminants, right? This is just A is between 5 and 8, and I asked you for the largest possible value, right? Therefore, the answer is 8. And this is one way that the question can be set as well, to be scary looking. And essentially, it's just them asking you to do the discriminant question twice instead of once, because the classic discriminant question in school, you have done it a lot. Let me make you do it twice, not in two separate questions, but two layers in the same question. And of course, as I said, I took a long time to pick the coefficients just to make sure that all the way down to the end, you actually get a nice solution. Question 18. This is a very American style thing. They like to self-reference the competition that is being that everyone is taking. So I'm like, okay, fine, let me do the same thing. But in doing so, they do distract you a little bit, because this at first you're like, haha, that's funny. And then after that, you're like, oh my gosh, there's so many variables. And you don't realize maybe that because of the choice, right? There are so many common variables, right? I mean, SMO is repeated, but so are a lot of letters in open and senior. And so you can really factor it as SMO and actually there's two O's, right? So this SIR is P on the other side is less than 0. This is such a sad thing to do to the inequality, but from a reading perspective, but from a math perspective, it just turns out to be a very easy to process inequality. Now take note that so there are a couple of conditions, right? The first thing is that you must make sure that this is not 0. This cannot be negative, right? But because it's strictly less than, so this cannot be 0. And if this is not 0, it's positive, then I need to make sure that this is negative. And SIR being less than P is quite hard to satisfy. So that is good because it makes it easy to count. Now, first of all, I'm going to deal with the 0 issue, right? If let's say S, M, O, E, and N are not 0, if P is 0, then of course this would already be positive. So it's just I or R could be positive. So it could be 0. I or R could be 0. If I or R is 0, you are already done, right? Because if I or R is 0, then there are another 7 letters, and they can be anything from 1 to 9, and it's also true. So it's 2 times 9p7, which is basically 9 factorial, because 9p7 is multiplied from 9 down to 3. Okay, that's a lot, but there's a reason why I asked you to divide by 10, right? The final answer of k is, this is already more than a 5-digit number. Okay, so second case is that they're all non-zero. Now, if they're all non-zero, that means that I need my SIR to be less than P, which is at most 9. So your SIR is at most 8, which doesn't give you a lot of choices for 3 different numbers, or rather 3 different digits multiplying to at most 9. It's just going to be either 1, 2, 3 or 1, 2, 4. Okay, so we should just be careful with this again, because they do give you different number of choices for each. So if SIR is the set 1, 2, 3, you have got 3 factorial for SIR. 3 choices for P can be 7, 8, or 9. And then after that, the other M, O, E, and N, remember they're all non-zero, so there are only 5 more numbers to pick 4 from. So it's 5p4, which is the same as 5 factorial. Okay. In the second case, where it's 1, 2, and 4, the same thing except that this 3 has only become 1, since the p can only be 9 if SIR 1 times 2 times 4 is 8. Okay, so this is 2880. You add up and divide by 8. Finally, for this video, which has been a bit longer, we have got our third-ish geometry question, depending whether you consider the quad geom question. There will be about 3 to 5 geometry questions usually. So this is around normal. I think there was a lot of geometry, relatively speaking, last year, 2024. And that is not necessarily an indicator because 2023 had a lot of number theory. If it happens again, we will know. But every year, the person in charge of the paper has a little bit of, creative license as to which topics you want to ask more. So, hey, 3 geometry questions is entirely possible too. Anyways, you actually have quite little numerical information here. The only things they tell you, or rather I'm telling you, is that line O1BA02. I tell you all the distances, right? This 8, 4, and 10, which means you also know the radii of the 2 circles, 8 plus 4 and 4 plus 10. That's all you know about the numerical information. The rest is just describing stuff about intersection after intersection and common tangent line, and then ask you for PC times PD. This question is using a simple idea, which is that the CD, this line here, is known as the radical axis. And just by symmetry, you know that it is going to be perpendicular to here. It's called the radical axis because the line is perpendicular to the thing that contains the radii of the 2 circles, right? There are lots of things you can say about this, therefore, including that PC times PD, because it's on the radical axis, by power of a point, you can say it's equal to PE squared, and you can say it's equal to PF squared, and you can say that, of course, PE equals to PF. So therefore, either one of those is enough. However, I still need to decide how to do it in terms of finding P and PF. So what I'm going to use is not that complicated. I'm just going to use the fact that this is a right-angled trapezium. And a right-angled trapezium, you've got more than enough information. If I just pluck it out, this is 12, 14, and 8 plus 4 plus 10 is 22. Then this is 2. And so by Pythagoras, this is square root of 22 squared minus 2 squared, which is square root 480. I'm just taking out 1, 2, because it means that both of these are equal to square root 120, which is what I want to use to find, right? PE squared and PF squared are both going to be equal to 120. When it comes to geometry questions, I said just in the previous video, a lot of times they either give you too much information where you can just bash, or too little information where you can just assume a special case. I think this is the sort of question where you have to actually do it properly because it lies in between, right? You can't just assume something of the circle since I told you the radii, but you don't really have enough lengths where if you just anyhow start bashing it with trigo, you will be able to get something done. All right, and so this is the end of part 3 of our video. In part 4, I'll go through the last 6 questions, and I'll also just talk through a little bit about some general tips as well as some views on the paper at large. But still feel free to express your any thoughts and comments, and I will see you again for the final part in a little while.